Welcome to those of you who are joining today's session. We'll get started here in about 2 minutes. Thank you. Glad to see more of you are starting to join today's session. We'll get started here in about just another minute or so. Give those stragglers a moment or two, and then we'll get rolling. Thank you. All right, welcome everybody to today's session. Let's go ahead and get started. So my name is Josh Brothheim. I'm the training manager at Sumo Logic. And what we're going to be doing today is going over, as the slide says, and as the class hopefully you registered for, going to be talking about AWS observability, utilizing a couple of really cool tools and features within Sumo Logic, specifically tracing and root cause explorer. So we're going to be together for the next hour. If there's any questions, go ahead and post them in the chat. I'll periodically kind of check in there. But let's talk about what we're going to do for the next hour. So introduction, kind of starting that already. And then we're going to talk about end-to-end observability and just do some definitions, kind of some level setting. Definitions is probably a better way to refer to it. I'm going to talk about AWS observability, and then we're going to really dive into the features that we want to discuss today, which are going to be those tracing and root cause explorer, or RCE as we refer to it. For those two portions, we're going to have some labs. So we're going to get interactive today. I'm going to give some credentials later. We're going to log in together and we're going to go through the application or go through Sumo. So if you've done that before, great. If you haven't, even better. And then talk a little bit about next steps and get you out of here a little bit early. So, all right. So this first slide is around Sumo Logic, kind of in general. If you've attended really any of our presentations before, we kind of utilize this slide. Just it's a good, once again, kind of level setting slide talking about Sumo Logic's continuous intelligence platform. Essentially what we're trying to show at the top of the screen with the 4 panels or 4 panes are the various ways that you can use Sumo Logic, and just some of the ways you can use Sumo Logic. There's many different ways, but you can utilize Sumo Logic for your operational intelligence and start to figure out, are your systems up and running? What is your MTTI, MTTR, those important metrics of mean time to identify or resolve, which are more and more important every day. You can utilize Sumo for security intelligence. Maybe you want to look through your data and look through your logs and see who is using root access. Is somebody logging in from 2 different places at the same time? Is that okay? And things like that. Business intelligence. What pages are people frequently viewing on your website? What are they ordering? If you ran a marketing campaign, was it successful? Things like that. And then global intelligence can start to tell you how are you doing compared to other companies, observing your data on a worldwide basis. And so once again, just many different ways to utilize Sumo. Sumo relies on your data. Without your data, there's nothing to do. we need your data. And so your data can arrive or come from a variety of different places. Might be generated from apps, might be generated from microservices, might be cloud data, mobile device data, etc. And so regardless of where that data is, and might be in multiple places, it needs to be collected and brought into Sumo Logic. And we have a course that we go through of our administration course of actually how to bring the data in. It's really kind of easy, but that's not our focus for today, of course. Now, once the data is in there, you can start to take advantage of our analytics, utilizing multi-tenancy. Everything is scalable and has elasticity. There's machine learning, APIs are utilized, advanced analytics, and we're going to talk about some of those advanced analytics a little bit later because we're going to use some of them, using security monitoring, making sure everything's good. On the far right, I'm trying to show here some of our certifications and attestations that we have. Very proud of them, the HIPAA, PCI, FedRAMP, et cetera, all very important. And you or somebody in your organization probably cares that we are certified in that respect. And then ultimately at the very bottom of who can benefit from Sumo or who can utilize Sumo, well, everybody in your organization, regardless if they're DevOps or engineering or et cetera. So yay, Sumo. All right. But now I want to get or start to talk about end-to-end observability with Sumo Logic. Now, before I do get into observability, I want to define monitoring as well as observability, excuse me, easy for me to say, and talk about the differences and the similarities because they are very, very similar, but there's a difference, and that's what I just want to call out. So let's look at these definitions. So a lot of people do equate observability to monitoring, but when we dig deeper, we see that it's not about just seeing when something goes wrong, but about what's causing it. What areas are being impacted and how can we correct it before it impacts more customers or more parts of an application? So how are they different? Monitoring is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored, then we have no idea what's happening there. And of course, knowing something is wrong is quite important. And so observability takes it a little bit further. It goes beyond monitoring. It's going to take our logs, our metrics, our traces to give us a broader view and a deeper context so that we can know something is wrong, but more importantly, or maybe equally importantly, be able to find out why, and then of course, resolve it. All right, a couple slides here. Yeah, a little heavy in the slides at the beginning, but like I said, I'll make up for it with labs in a little bit. So we have our iceberg slide here. And what I want to call out is the fact that observability is going to require more data and richer analytics as you go from alert to a problem resolution. Let me get the slide loaded so that we can see the three layers of this iceberg, if you will. So at the very top, we have the what. And so monitoring is pretty easy, doesn't require much data, and can, like I said, can kind of tell you the what pretty easily. But you want to get deeper with observability. You want to start to know the where, the why, the how. And by doing so, it requires more data. And so I want to talk about that because the observability solution should be able to handle large scale data sets. While monitoring and diagnosing require working with some amount of data, it's the troubleshooting phase, and this step 3 at the very bottom, that is where the observability system should be able to handle essentially unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observability solutions that don't have a high-end and highly scalable solution. Well, fortunately for you, built on a cloud-native architecture, Sumo Logic enables the ingestion and storage of any amount of data in a highly elastic and flexible way. The second portion of the observability solution is that it's going to need to have a very scalable analytics engine. Observability is going to require you to analyze lots of data to machine learning, and other initiative search-driven analytic capabilities. Well, as a large-scale machine data analytics platform, Sumo Logic provides those out-of-the-box capabilities to support the ingestion and analytics of any amount of data. Now I'm going to show this next slide. It's this portion. So once again, that highlighting of showing as we get deeper into our analytics, we need more data. Now flipping the monitoring, diagnosing, troubleshooting kind of on its side here is the fact that the important or one aspect to achieve end-to-end reliability is going to be that unified observability platform. And what does that mean? Well, what it means is starting on the left-hand side of the screen, we have the requirement or the need to get all bits of data telemetry into the system to perform the tasks that teams who are in charge of reliability and DevOps are going to need to utilize. And so that's going to need to be pulled from each and every layer that affects the application. This data could be coming from your hosts, your servers, your application components, your databases, pretty much everything in these boxes on the left-hand side of the screen, many different environments, Kubernetes clusters. And in addition, or even beyond that, you might have your CI/CD pipeline, your CDN services, load balancers. And it's required to have all relevant data, such as these metrics, these metadata, logs, traces in Sumo Logic in order to provide that visibility. And so this is going to allow you to not just monitor alerts, but start to get deeper. Go from monitoring to diagnosing to troubleshooting. So once again, that theme of those monitor, diagnosing, troubleshooting, you'll hear maybe, actually, I was going to say a few times throughout today, really just one more slide. I think I mentioned it, but that's just stressing that completion of the observability, not just monitoring, but going deeper. All right. So I think this is the last slide I have about it, and just want to talk about one more time. So what value can somebody that's part of a team get from observability? So for example, the SER or the DevOps team, those individuals that are going to be responsible for monitoring the health of the application, they need observability. Why? Well, they need to be able to quickly monitor, diagnose, and troubleshoot application health issues. Who else can benefit from observability? Well, observability is going to help the software engineer on the team by providing visibility into the software pipeline. By collecting the information about the software pipeline and identifying issues with the software delivery process, teams can improve the quality as well as the delivery of their application. And then DevSecOps, observability is going to help those security teams ensure the security posture of their applications. And what's unique about the Sumo Logic observability solution is that it addresses the needs of all these teams and personas in one integrated platform. And we'll see that once again shortly. Let's see. This slide, I'm starting to get a little repetitive with it, but once again, on the left-hand side of the screen, showing that monitor, diagnosing, troubleshooting. But what I'm showing on the center of the screen, or I guess the center portion, is how, as you want to get deeper into that observability of monitor, diagnose, troubleshooting, you need to get deeper into your data, essentially. With the monitoring, it's very easy to create, or fairly easy to create a graph, as we're showing here on the very top of green, red, and having something weighted in between those. That's not very hard. But what does get more difficult and requires more data is getting deeper, starting to look at the deployment layer, going deeper into the cluster, actually getting down to the pod layer, and ultimately the component layer, just continuing to drill down further and further to ultimately get to that root cause. All right, now I mentioned advanced analytics earlier. In Sumo Logic, we offer advanced analytics. Once again, this is utilizing the monitor, diagnose, troubleshooting theory, if you will. And we see here a variety of different analytics that can be utilized. The one we're going to be using today is actually on the bottom right of this screen, which is under troubleshooting, which is going to be the root cause explorer. Outlier is great. It's a great feature. We have prediction. We're just not covering that today because we only have so much time. So root cause explorer is where we're going to focus on our exercise in just about 5 minutes. All right. And then I like this quote. I find it funny. I don't know if you will, but what it says is we replaced our monolith with microservices so that every outage could be more like a murder mystery. And what this quote, that's now getting close to 10 years old, is describing is the idea of utilizing some idea of observability to find out what's occurring, where it's occurring, why it's occurring. So it's no longer just a monitor alert saying this is broken or this is down, or this is producing errors. We can now, if you relate it to the old board game Clue, we can now figure out that it was Professor Plum and the observatory with the wrench and really get down to the details. And it does essentially, or can read like a murder mystery. Not usually as thrilling, but can have some twists and turns in there. All right. So what I want to talk about next here is the Sumo Logic AWS observability solution. So tying the two together. Talked about Sumo Logic, why it's good, yay Sumo Logic. Now let's talk a little bit about AWS observability. And let me get this loading. Come on, slide. There we go. So AWS encourages the use of separate AWS accounts to help manage costs and give teams independent administrative control. Additionally, different accounts often have different settings across regions depending on the needs of a specific app. Once you're in a certain account and region, there's a multitude of services that customers can use to run their apps. And within each service, for example, EC2s, you have multiple entities, you have multiple instances that correspond to it. They might have their own data monitoring. The problem with all this complex hierarchy is it often leaves vast data silos where it can be difficult to acquire a clear picture of overall AWS service health across regions and accounts. So as I'm trying to show here, and this is probably familiar to you, you might have multiple accounts spread across multiple regions, and we find that about half of customers do. You're probably using more than just one service. Maybe you're just using EC2s, but you're probably using something else that's connected to it. And so you start to utilize a bunch of services, which is great. They're there. That's what they're there for. And they're wonderful services to utilize, excuse me. But that challenge there is, once again, that visibility across those different accounts, those different regions and service hierarchies. And so that can make troubleshooting complex. There's just a lot going on. Now, what we want to do is, from the complexity and chaos of the left-hand side of the screen of those AWS features and tools that you're using, provide some clarity and root cause. And so that's what we're showing on the right-hand side of the screen, is taking all that stuff and presenting it in something that's a little more helpful. And so looking on the right-hand side of the screen, we can see that there might be API gateway errors. We see some red in there, et cetera, et cetera. We'll look at these in app in just a moment, but we get that visualization, which is really, really powerful, really simple to understand, or easier to understand, maybe not simple, but all right. Let's see here. So let's go ahead and, so what I want to talk about next is Root Cause Explorer, and have us start to jump in there. So what we're going to do with Root Cause Explorer is utilize it to accelerate troubleshooting and start to pinpoint the root cause of an incident. And we'll just talk about the incident in just a moment. So Root Cause Explorer is an add-on to the AWS Observability solution that's going to help on-call staff, DevOps, whomever. It works by tracking CloudWatch metrics and establishing a baseline of what a normal day or week might look like. And then it's going to record or point out, or highlight is a better way, out of ordinary events, unusual spikes, and different, essentially, events of interest, as we call them, EOIs. Yeah, well, I don't really want to talk about it, rather we'll show it a little bit. So let me go ahead and let's see, how should we show it? I'm going to show the screenshot real fast, and then we're going to jump into it. I'm not going to do a demo. I'll do a demo with you so that we can play together. But essentially, this screenshot is what Root Cause Explorer looks like. It looks busy, as it should, but as you'll see, there's ways to modify things. But what we're seeing essentially here is a graph at the middle of the screen. And we have our x-axis and our y-axis. Our x-axis is representing time. So in this case, we're looking at the last 3 days of data. And so that's what we see from left to right. On the y-axis, though, what we see, or not though, we see is our drift. And what we call drift is essentially deviation from the norm, is probably an adequate way to put it. And so as things get higher on the y-axis, they're more unusual, more outlying, or more of an outlier from a previous value. We also see in these colors here, these different categorizations that are utilizing what are called golden signals to start to show what these things are. Are we getting a bunch of errors? Are we getting some throughput? Are we getting successes? Are we getting latency, et cetera? And how are those being grouped together? So in this picture, on the left-hand side of the screen, from about the middle, there's a pretty good division of just seeing errors on the left. And then on the right, we see more stuff, and we'll go over that stuff in more detail. We then have the ability to start to click on these events of interest, these dots, and view metrics on the right-hand side of the screen, and start to see what the value was today, what it was yesterday, or a previous period of time, and start to see that difference, that unusualness, unusualness. We'll use that as a word for now. All right, so what I want to do, like I said, is jump in because that's more fun than just showing you a screen. So I'll get you logged in, then I'll go back to that slide. So for today's class, let me go ahead and put these credentials in the chat. We're going to utilize these for our training environment. So if you already have a Sumo account, that's great, but I'd want you to play along. So I want you to use these accounts, this account, excuse me. If you've used accounts with us before, you kind of know the numbering scheme. If not, I'm certainly going to discuss it right now. So to log in, we're going to go to service.sumologic.com. You might go someplace different for your real Sumo account. It might be service.us2.sumologic.com, but for today, we want you to just use service.sumologic.com. The email I want you to use is training plus analyst number, and I want you to pick a 3-digit number. So maybe you want to be training plus analyst 007@sumologic.com, training plus analyst 654-918-32, whatever. Pick a 3-digit number. And then that password of security22 exclamation point is, well, that's the password. And these credentials are going to be good for actually about 2 more weeks, 3 more weeks. So feel free to utilize these after today's session. So go ahead and log in. Once you get logged in, if you could just let me know what number you're using. If there's duplication, it doesn't matter today. I just want to make sure that you guys can get in. If you don't want to log in, that's cool. I'm going to show everything, so you'll still get the experience. And I'll give everybody, like I said, just a moment to kind of catch up. So hopefully you're logging in, and let me log in as well because I want to play. So going to service.sumologic.com, doing training plus analyst 234@sumologic.com, and then that password of security22 exclamation point. All right, so hopefully you're logged in. Once you're logged in, I'd encourage you to close any tabs that might be open. Remember, this is a training environment, so somebody may have logged in previously, and it doesn't matter, but it might just be messy. So you can choose to close tabs, or what you can do is close all the tabs. And so I'd encourage you to just do that. If you need help logging in, please let me know. You guys are kind of quiet, which is fine. I just want to make sure we're together, so, and nobody's left behind, really. All right, and what I want you to do is get to a screen that looks, well, exactly like this, or pretty similar. All right, now before we poke around, and feel free to jump around. I mean, I've given you access, that the keys to the kingdom. I expect you're going to probably start jumping around and poking around and going on your own tangent, and that's fine. I don't care. That's a great way for you to learn. So feel free to poke around. But what I want to do for those that aren't and that are with us is set the table for this example that we want to use. So the example we want to use is you're an employee of Travelogic, or our sister company that's in charge of booking flights and airfare and things like that. And you've been brought in as a DevOps specialist. And so your area of expertise is, or area of focus is AWS services, of course, but easy for me to say, specifically ELB, those application load balancers, host EC2, and DynamoDB. And the scenario on your first day of work is that end users are experiencing an outage in the application and getting 500 errors in the US East 1 area over the last 24 hours. So welcome to work. Now let's go ahead and start to look. So we're being told that 500 errors are occurring. Well, let's go look for them. Let's see if the system is identifying them. And so that's what I want to go ahead and do now. So the way we're going to do that is we're going to go into Sumo Logic. And we're going to go to, we're not going to use Root Cause Explorer yet. We're going to get there, but I want to show you a few things kind of on the way. What I want you to do is click on Explore, or go to plus new and Explore, or choose to use the keyboard shortcut of Alt-G. Regardless, get to Explore. Now, once you're in our Explore view, it may show nothing, and that's okay. We're going to get to the rights portion. Remember, this is a training environment, many different scenarios in here, and so we want to get to the place that we are interested in. What I want us to do is I want to go to the Explore by on the top left, and I want to select, and I want you to select AWS Observability. If this was a Kubernetes class, we'd be diagnosing these Kubernetes metrics and views, but that's not today's class. Today is AWS Observability. So once you're in AWS Observability, what you're seeing, it might take a moment or two, are your different, by default, your different accounts. So what I have here is I have a prod account, I have a dev account, I have a staging account, I have some testing, a mobile banking production use case that we use. And what I'm seeing now is all this information. So remember, I said previously how difficult it was to get an understanding of your different environments. Well, here's my dev. Here's all my people that are coming in for my dev activities. Oh, I want to look at prod. All right, now I'm looking at prod. And take a second or two to load, but now I'm able to get this visualization of what's going on in my production environment. I mentioned earlier, a few times, US East 1 is what we want to look at in this case. And the challenge of looking at US East and US West, that's, how do you do that? Well, if I want to go to my production US East 1, click on production US East 1. If I want to go to US East 2, I go to US East 2. In this case, I want to use US East 1 because that's the scenario. And so what I want to show here is now I'm looking at specifically production US East 1. Now, what am I seeing in here? Well, I'm seeing a bunch of stuff. May be relevant to what I need to utilize, may not be. Remember, this is training environment, so there's just a lot of, like I said, a lot of stuff in here. But what I want to go to is, where do I want to go? I want to go to the AWS application ELB. Because what I want to show you is the system recognizing that we're getting a lot of errors. Now, from this view, everything looks kind of okay. There's this portion here, which is related to the 500 errors. But I want to scroll down just a little bit further. And I want to point out this particular graph or chart. Or graph, I guess, same difference. What we're seeing here is 500 load balancers. And what we're seeing is here, different, essentially load balancers that are exist, the 4 of them that are underneath the ELB. And what we see is the occurrence of them. So for example, for this blue line here, it's high, but it's consistent. And consistent is kind of good in this world, especially in these use cases. These other load balancers, they're consistent. But what I see here is a spike of 500 errors at 2 particular times. The reason it's occurring at 2 particular times is because this is a demo environment or a training environment. And so we replicate the data twice a day. And so what I'm showing you here, or what I want you to kind of lead your eye to, is here are these 500 spikes that are occurring that we need to look at. And so here's the start of the visualization that's showing us, hey, these spikes are occurring. And now I can start to dig deeper into find out what caused them. All right, so hopefully we're together. So what we just did there is we used the Explore view, not root cause Explorer. We're going to do that right now, but just the Explore view to, as described, explore. If you're poking around, and I hope you kind of are a little bit, there's many different dashboards that you can start to look at. Should load a little bit faster than that, but that's okay. And so what I'm starting to now see are different views, different events of interest. Now, this event of interest I referenced earlier in the ability to start to use Root Cause Explorer. And what I'm viewing here is kind of like a mini Root Cause Explorer. It's not really what I want to show you. What I do want to take you into is the real Root Cause Explorer. And so what I want us to do now is to go to the plus new and go to root cause at the very bottom. And so what should open up is something looks nearly identical to this. It might take a moment to load. What it's doing is it's looking at the last 3 hours of data and starting to look at the different, once again, events of interest and categorize them. Now I want to do a couple things here because I want to show a specific example, but the example that has occurred about 4 hours ago. And our graph here shows us the last 3 hours. And so what I want to do is go back a little bit further. And so what I want us to do is click on the 3 hour the time setting and choose last 6 hours, just so we can get that that test data that happened, like I said, about 3 hours ago. So it's loading. It's going to take a few moments because now it's grabbing more data. It's populating on the screen. It should be just about, yeah, there it goes, just about, well, it's still loading, but it's pretty much done. Now I want to modify this because this is showing us a lot of data. And what I have the ability here is to utilize filters. By default, it's going to look at AWS data. It's going to look at Kubernetes data. It's going to look at application service data and show all those events of interest. Now, for this example, once again, I don't want to show Kubernetes data because that's not today's conversation. And so I'm going to turn off the Kubernetes toggle. When I do, you should notice this graph cleans up a lot because a lot of those events of interest were related to Kubernetes, which is not today's conversation. The other thing I'm going to do here is really just in the interest of cleaning things up is I'm going to go to my region and I'm going to select US East 1 for the same idea. The US East 2 stuff is just not relevant for today. And I just want to clean this up really as well as I can. And so I'm going to click on US East 1 and really do that much, but it is a little bit cleaner. All right, so what I want us to focus on now is are the events that occurred at 6 a.m. or actually prior to 6 a.m. So really 5 a.m. to 6 a.m. Pacific time. So if you're logged in, it might show a different time zone, but these guys right here. And now what I want to do is start to look at them and start to understand them. The system is telling me, hey, these are interesting. These are worth checking out. Well, all right, let's check them out. Let's see what it's telling me. What I'm going to click on first is this red guy. What this is showing me is very similar to what I just showed you earlier. Actually, excuse me, I take it back. It's a little bit different, but it's the 500 errors. So what I'm seeing is the system is telling me, hey, at about 5:30 to 5:50 local time, we had a lot more 500 errors than were expected. That drift is showing 729% higher. And what I'm seeing here is a visualization of that. This visualization is showing me today's data that happened about 3 hours ago. It's showing me yesterday's data, and it's showing me the week before. So essentially today's data, Tuesday, Monday's data, and then last Tuesday's data. And what I'm seeing here is at about 5 a.m., I'm seeing the blue, the green, and the light blue. And I'm seeing there were some 500 errors, clearly, but it's pretty low. Yesterday, same thing. 500 errors, but at least they're pretty low and consistent. Last week, 500 errors, but they're low and consistent. Now, when I look at today, I see low and consistent, but at 5:30, I see this peak, this spike. Well, why are there so many 500 errors at this time? Normally there aren't. This is at least an anomaly, an outlier, unusual activity. And so I want to figure out what caused those. So how am I going to do that? Well, I'm going to continue to use Root Cause Explorer because what it's showing me is previous events. Prior to the 500 errors, the system is letting me know that there was a bottleneck related to EC2. If I click on this guy, going even further back in time, I'm seeing a DynamoDB error, a DynamoDB bottleneck. And then once again, I'm seeing a similar visualization where we're seeing the right throttle events. Normally they're, up and down, but once again, they're really spiking at this time. And so this is starting to lead me to dig in to see what occurred, when did it occur, what occurred previous to it or prior to it. Another way to view this information, which might be more helpful, is this view here. And so what this is showing us, it's just personal preference, really, I guess, are a different way to view the activities that took place. But the visualization here is pretty nice. And so what we can start to dig into is, or what we did start to dig into, is the events of interest, the 500 errors. And so what we're starting to see is that spike in right throttle events that are then causing this. Now, what we could do, and I was having some issues with this example, so I'm not going to do it right now. But what we could start to do is start to dig in to our logs. And what we could start to do, and it's just not working here for this example. think I have too much narrow a time zone. But what we can start to see is what tables were being updated and who was doing them, and possibly if they caused some issue related to the right throttle events. And so that's how we can use Root Cause Explorer very simply, is to have the system show us what's an anomaly. All right, let me go back to my slides here. I know I skipped around a little bit. So we saw that. We looked in RCE. Yeah, pretty good with RCE. And so RCE, or Root Cause Explorer, as mentioned, embodies 5 concepts. Abnormal spikes, not to read the slide, but those are going to be indicators of a problem. As we saw earlier, having errors isn't having errors is normal, but having spikes of errors, that abnormality is kind of weird. Using context and correlation of spikes. When did something occur? When did something else occur? Was it during a similar time period? And is there a connection? Looking at the resources and the services to start to look at the EC2s, look at the DynamoDB, and trace those. The earlier spikes, something happened and then something else happened. Doesn't happen in a vacuum. And then using the log exploration. So we didn't get that deep, but we could start to actually look at our logs to identify the root cause. And in this case, what it would have shown is somebody actually messing around with the right throttle events and just doing so incorrectly. And so it could just be a training issue. All right, let's see. Time-wise, we're doing okay. So what I want to talk about next, let me go ahead and we'll do a few slides here, and then we'll go back into the application pretty quickly, is tracing. There we go. So tracing is going to play a crucial role, excuse me, in tracking transactions of an app on a microservices-based architecture. So even a simple 3-tier application like Sumo Logic Coffee, and I'm going to introduce that in a moment, is going to potentially need a load balancer, a couple servers, a database. And so remember, observability is being able to ask any question you need about your application and how customers are interacting with it. And so with Sumo's query language, you can do this with logs and traces. And this is a large differentiator because no other tool provides the ability to slice and dice your span data using a powerful query language like Sumo's. So let's go ahead and look at tracing, and let's utilize a specific example. And the specific example we're going to use for today is Sumo Logic Coffee. You may be familiar with Sumo Logic Coffee because we have thousands of locations around the world. You might not be because it's a fictitious company. But for today, we're going to assume it's a production environment, and very similar to a company that has a green logo. We make coffee, and as it says, a hot, fast cup of coffee is our priority. And so how are we going to start to use technology and computers and servers and, to measure the delivery of coffee? Well, let's go ahead and talk about that. Now, a successful order at Sumo Logic Coffee is going to follow these steps. A customer is going to place the order, probably using our app, but maybe they do it in person. The order is going to get to the barista. The barista is going to start the coffee machine. The coffee machine is going to be doing a lot of the heavy lifting here. The coffee machine is going to check that it has adequate levels of ingredients, that it has the proper amount of beans, and start to grind those beans. It's going to make sure it has an adequate amount of water. And if it does, add the water and stir it all together, do its magic. And now the coffee is ready for the customer. Now, Sumo Logic Coffee, we are a for-profit organization. And so payment is going to be needed. The customer is going to need to pay for that order. Credit card is going to need to be approved. We don't use cash anymore. We only use cards. And then the customer is going to pick up their order. And then we have a happy customer. They have their hot coffee. And in that regards, each step is like a microservice. Something happens, next step happens, next step happens, and so on and so forth. Now, what we're going to do now is start to look at those microservices occurring. And that's what this chart I'm trying to show is the idea of you have your Sumo Logic Coffee, that gets placed. Then that order essentially gets split off into those microservices of the machine service and the payment service. The machine service is responsible for brewing the cup of coffee. On the other side of the house, we have the payment system, which is responsible for calculating the cost of the coffee. How much was that cup of coffee? Looking at the SQL records for various drinks, using a calculator service to add it up, add tax, do what it does, and provide that value. And so once again, it's just like microservices. All right, I'll do a few more slides here, but then I want to get into this, a couple more slides. And I want to talk about service maps. What service maps are a constantly updating diagram or map of your services and the interactions they have with each other. Each service is shown as a bubble, and an arrow is going to connect the service which calls one another. And so these service maps, let me show you the next screen rather than just talking about it, is going to start to show you what's taking place. So what I have in this example, and I'm going to show it in app in just a moment, but if you want to go in app ahead of me, that's fine, is the service maps. I've narrowed it down specifically just for our coffee bar app, which is our coffee bar app for today's discussion. And then what we see here are the different services or different services. And with those different services, we also start to see where errors are occurring. Or not necessarily, well, they would be errors, but really outliers. And so here we're starting to see that there's some latency occurring. Now, what I'm going to do, I think I'm just going to jump into it and have you, let's look at them together. So what I'm going to do is I'm going to go into Sumo. I'm going to go to plus new, and I'm going to go to service map. And when it loads, it's now going to show me all the applications that it's identifying in my account or in my environment. Now for today, we only want to use the coffee bar app, so we're going to select that. And what we now see is a visual representation, a map, if you will, of our coffee bar application. And so we can start to see in here what services are being utilized, what languages they're encompassing. So for example, here we see Ruby on Rails is being utilized. The icon is specific for that. And we can start to click on these items. So for example, what we're seeing here is the coffee service. Let me just mouse on it, is having some latency. And it's abnormal. Similarly, the water service is having some latency and it's abnormal. And we're going to dig into those in just a moment, but that's what we're starting to see here. We also have, let me go ahead and just show this because the question usually comes up is how are these being determined to be normal or anomalous? And in our settings, you have the ability to start to define that. So it's using similar ideas as outliers, which I referenced earlier, didn't show. That's a totally separate class. But you can start to decide how essentially aggressive you want to be with these the visualizations of normality versus anomalies. All right, so that's service maps. Let's go ahead and take a look at, let's see, we're going to do traces next. Let's go ahead and do it through the plus new. So what I'm going to do is I'm going to do plus new, and I'm going to do traces. Now, what traces are going to show us? There we go. And hopefully you have a screen that looks similar to this. We're going to use some filtering in a little bit. But what we're starting to see in here are the various components that occurred related to our, in this case, our coffee bar app. So essentially different orders that have taken place. We can go ahead and filter in here. So we can specify our application is the coffee bar app. And what we're now starting to see are some transactions that are taking place. Now, I'm going to show this in a different way. I should have I should have used the screenshots probably for this because I want to show it a little bit differently. What I want to do here, let me see how the best way to show this. Let's go back. Actually, we can do this together. What I'm going to do is I'm going to go to my coffee service. So I'm going to go back to my service map, sorry. And I'm going to go to, I'm going to select let's do my water service first. So I'm going to click on the water service icon. And then what I'm going to do is on the right hand, a nav bar or window should pop open. And I want to go to open in traces. And what this is going to do is it's going to now show me just those traces, just those transactions, if you will, that are part of the coffee bar apps or part of our use case that have the service water, that have the water service as part of the microservices. So it has that component in it. Now, what I want to do here is I want to start to look at some of these because the red was bad. There was an anomaly. The system was telling us something was wrong with the water service. And so what I want to do is start to look at these and start to look at one that has an issue with the water service to see if I can figure out what went wrong. So what I'm going to do is I'm going to select one of these. Now this is going to be a little tricky. I want to look for one. Let me see if I can find one. So I want to find a trace that when I click on it and zoom in on it, it has red, which most of them should have red. But what I want to look for specifically is red at this little guy or this little guy. If it's red for the green, I don't really care about it for right now. It's just, I don't want to show that in this example. But I wanted to look at these. So I want to look for, this one is okay. So this one has red at the coffee service level. And so I want to figure out what has gone wrong with this issue, this order. Something has gone wrong with it. The red represents an error. So what has gone wrong? What I'm going to do is I'm going to take a look at our logs here. And so let me just show you how I did that because I kind of jumped around. So I'm looking at my traces. I'm looking for a trace that has a red line either at the coffee service or at the water service. Wherever the red line is, I'm going to click on that little box. And then I'm going to look at the logs, specifically the logs that are tagged with the span ID. And what this is going to show me is what went wrong. With this order, an order was received for coffee grains. The system did not have enough coffee grains. And as a result, it resulted in an error because the system did not have enough coffee to brew the item. And so that's what was the issue here. And so what traces is letting us do is start to look at these transactions and give us the ability to see the various steps that occurred in there. If we go back to the trace view, we start to, let me zoom, I guess, either way. But we start to see the various components that I referenced earlier in placing an order. So we see the order that took place. We see the coffee machine looking for the ingredients of beans and water. We see the payment occurring, and so on and so forth. And so this tracing gives us really just a nice view into that understanding of what's taking place. All right, the last thing I want to look at, probably the last thing we'll do is spans. So, I meant to do traces. I meant to do spans. So what spans are, as give me a little highlight, is the ability for you to start to create an analysis, essentially a query on tracing data. And this is a differentiator for Sumo Logic because many systems can't do things like this. And so what we can do is we can now filter on our tracing data. And so to do so is really kind of quite easy. We're going to add a filter. And then we're going to decide what will be visualized on the chart. So for this example, what I want you to do, let me see, I think I have a slide for it. So we're going to go to plus new spans. And then what I want us to do is, as it says here, I want to filter and look at the front end activities of the Sumo Logic coffee bar. So I'm going to utilize the filters here. And let me kind of do this off screen a little bit. I'll do it down here, I guess. So I'm going to do my filter. It's going to be the service equals the coffee bar front end. Now, what do I want to visualize? I want to visualize duration, and I can choose. And as you see, the system is actually walking me through this. I can go ahead and specify my time. And then I can choose to limit. Limit to 5. All right, and so what we're starting to see now here are those analytics that are taking place. We can look at those messages as well. Come on. There we go. And with the messages, what we have the ability to use or use are these things that we call facets. It's very similar to if you've used our just log queries and used our the log explorer on the left-hand side of the screen, similar to that. And so what we can do is we can view just different values if we want to add them in here. We can also filter as well. So if we want to just specify a particular component, we can go ahead and do so. And so this is giving us just more control to start to look at our traces, look at our spans, use a query language to start to slice and dice that together, and ultimately in the benefit of observability, giving us more insight into our systems, into our environments. All right, let's see. I think I'm going to start to wrap things up. I am. So let me, I think I just have one slide here to kind of, yeah, that's the quick slide here. So in conclusion, we looked at service maps, which were are utilizing real user monitoring, the dashboards to provide that customer experience of how our web app is being utilized. We used tracing, and tracing was helpful to drill down into the logs and find potential causes for a situation. Did the system have enough coffee grains? Did it need more water? And then span analytics, we can start to use the query language of Sumo and take a look at those spans and start to slice and dice those to get a better understanding. All right, the last thing I want to talk about, just very quickly, and not that, is just unified alerting. Because alerting is important. We don't really probably cover it as much in this course as we should, or this workshop. This slide is really my only allusion to it, but the ability to start to create alerts on logs, on metrics, and to be notified. There's a lot of power in that. Of course, it's great to go into those observability explorers and just poke around. There's a lot of value in that, of course, of just going into new and explore. And like I said, looking around, seeing what's going on, but creating an alert is going to be more helpful so that if something does spike or is an anomaly or an outlier, the system can notify you of it via email, webhooks, many other methods. And so that's really just an important piece of all this is the ability to maybe ironically stay out of Sumo Logic and still get power from it. All right. So yeah, that really concludes today. I'll go ahead and put some of these links in the chat. I should have done this earlier. Just various support articles that are related to some of the topics we discussed today. And just remind you that if you want to get more training, and training is free at Sumo, you can go ahead and go to this URL that I'm trying to paste. There we go. Oh, regardless, there it is. Sorry about that. So great place to get more help about Sumo. All right, so I wanted to thank everybody for attending. Hopefully you learned a little bit about Sumo, learned a little bit about observability, how it all ties in together into getting a better view into AWS understanding. And thank you for attending today. So enjoy the rest of your day and hope to catch you at the next session.